Hello everyone, welcome back to the another session in Design and Analysis of Algorithms, Unit 2, Topic 2, Binary Search. So binary search is actually a divide and conquer strategy. The name itself, it says that we are searching an element. So let's see how binary search algorithm will works. Let assume one list of elements, where the list of elements are ai. I lies in between 1 to n, that sorted in non-decreasing order. That means ascending order. This is the first constraint of binary search. It should be on sorted order. Consider the problem of determining whether a given element x is presented in the list. If x is present, we ought to determine a value j such that aj is equal to x. If x is not in the list, then assume j is 0. Let p is equal to n comma ai to al comma x. Denote an arbitrary instance of this search problem where n is the number of elements in the list, ai to al the list of elements, x is the element what I wanted to search. Now, divide and conquer can be used to solve this problem. Let small of p be true if n equal to 1. In this case, s of p will take the value I if x is equal to ai. Otherwise, it will take the value 0. Then g of 1 is equal to theta of 1. If p has more than one element, that means my n size is greater than 1. It can be divided or reduced into a subproblem as follows. Now, pick an index. So this case is what? When n is greater than 1. Pick an index which is q in the range I comma l, where I to l array size. That means you can assume I is the starting size, I is the starting size, L is the last size. So that is I is low index, L is high index. So now we have to pick an index which is Q and compare X with, what is X? Searching element, what the element you wanted to search from the list. And compare X with AQ. So Q is what? An index from the A array or A list. Now, there are three possibilities. The first possibility is what? X is equal to AQ. In this case, the problem P is immediately solved. In the first comparison only it will get solved. The second comparison is X value can be less than from AQ. In this case, X has to be searched for only in the sublist AI comma AI plus 1 up to AQ minus 1. As I said, that list is sorted manner. When the searching element is less than from AQ, the searching should be done in this range. Okay. Now, therefore, P reduces to what? Q minus I comma AI to AQ minus 1 comma X. This is one subproblem you can assume. The third possibility is, the third case is that X can be greater than AQ. In this case, the sublist is to be searched is AQ plus 1 to A of L, not this side. Okay. So as the list is sorted fashion, you can assume this also. If the list is sorted fashion, that means AI to AL. So if the middle element is X element, that means you found X element in AQ position, then this element will be AQ minus 1, then this element will be AQ plus 1. If X is less than from AQ, then searching will be done left side. If X is greater than AQ, then searching will be at this side. That means this is first possibility, second possibility, third possibility. So in this case also P is reduced to L minus Q comma AQ plus 1 to A to L comma X. In this example, array any given problem P gets divided or reduced into one new subproblem. This division takes only theta of one time. After a comparison with AQ, the instance remaining to be solved, if any, can be solved by using this divide and conquer again. If Q is always chosen, such that AQ is the middle element, that is Q is equal to I plus L by 2. Then the resulting search algorithm is called as binary search. Note that the answer to the new subproblem is also answer to the original problem P. So what does it sense? That there is no need for combining the solution. Now we'll see how recursive binary search algorithm is. Now a recursive approach binary search algorithm. Now I'll write the binary search algorithm. After this we'll see one example also how binary search will work. So I'm taking binary search function where my function is having 4 arguments. So as I said earlier, A is the array of size, I is the low index, L is the maximum index or high index, X is the searching element. Now if L is equal to I, that means what? Array is having only one element. That means I am denoting with problem is very small. So then what happens? Our searching element will get compared with X is equal to A of I. That means we'll return I. Else will return 0. Now the case is what? Else case. This else case is what? Problem is reduced to subproblem. Now in this case, so as place is not sufficient, I am taking the other thing. So you might have understood this, that when problem is small, that means your array is having only one element, that high index equal to low index. Then our searching operation will take only one instance of time. Else case is what? If problem is bigger one. If problem is bigger one, what we will do? We will be going to divide, as I said, or as we were seen in the divide and conquer approach control abstraction algorithm. Problem will be get divided into subproblems. So now mid is equal to I plus L by 2. I am calculating the middle element. Now if my searching element is equal to X is equal to A of mid, then we'll return mid. Searching was done in the first comparison. If not means else. If the second possibility X less than A of mid, then what we will do? We'll return binary search operation which takes place left side. That means I value 2 mid minus 1. Even this case also not possible. That means the third case, return binary search will do a recursive approach A comma mid plus 1 comma L comma X. And this is what binary search algorithm, right? So this is what recursive binary search. it means that we can also do binary search with the iterative approach. So I am showing only recursive approach. We'll take some example and we'll solve some binary search problem, how it works. Now the example is, I'm taking a list of element, my array size is 10. That means A of 10. Now my I value is 0, index starts with 0. My L value is 9. So total 10 elements I said. Now X is my target element. Let us assume I wanted to search for 25. Okay. Now this is what your given inputs. Now here we go with the binary search, how it works. So let's assume that I'm taking array of 10 elements, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now I'm taking the elements which are 10, 15, 20, 25. So you can take any element. It doesn't mean that the same elements you have to take. So just I'm taking for the convenience, that's it. There is no logic to take the elements. You can take any element. Condition applies, all these elements should be sorted manner, non-decreasing order. Now, your target element is what? X equal to 25. The very first job is what? You have to find out the index of Q. What is Q? I plus L by 2. Low, high and middle element we have to find. Low is what? 0. High is what? 9. Middle is what? Low plus high by 2. That is 0 plus 9 by 2, which is 4.5. Apply floor value, you will get 4. Okay, now. So what is 4? Middle value. We wrote 3 possibilities, right? So what is the first possibility? Target element has to be compared with A of mid. What is middle element? 4. So that means X is equal to A of 4. What is X? 25. What is A of 4? 30. 25 is not equal to 30. So now if condition has failed, else if 25 less than 30. Now this condition is true. 25 is lesser from 30. So searching operation will be at this side, left side. Means recursive operation, else if condition has been processed. That means searching operation will be 0, 2. That means A of I to A of Q minus 1. That means 0 to Q minus 1 is what? 3. These are the reduced sub problem. So searching operation will be here. Now this time your low value is 0. High value is 3. Middle value is 0 plus 3 by 2. 3 by 2, which is 2. Now 2 is what? 20. So again 25 equal to 20. Condition fail. So when condition fail, else if 25 less than 20. This also fail. 25 greater 20. So searching operation yet right side. Right side means from this to this. So now your element is in middle position. The first case will get pass and searching element has found successfully. So this is what binary search using divide and conquer strategy. Thank you all.